Goed. Goedemiddag. Good afternoon, everyone. So we are here for the business defense. So first of all, we'll discuss the procedure. So you will have 15 minutes max to present your work. Then we have 30 minutes max to question you about what you have presented and also what you have written down in your thesis. Then we will ask you to leave, so then your job is done. And then we will also do the evaluation if there's time, depending a bit on the agenda of the colleagues. And then you will get your results, your feedback in Plato. I think it will be somewhere next week. The faculty will announce it. So we will not announce any scores, so it will be by the faculty that will be announced, but of course, feedback will be there in Plato. If you still have additional questions, you can always contact us. I will just close the door.
Are we still waiting on Kenzo or no?
Kenzo is abroad.
Kenzo is abroad, okay.
So he's not here till mid-July or.
But he has already evaluated the thesis.
He did the evaluation of your text.
Yeah.
That he will not be here for the evaluation and presentation.
Okay.
Okay. Yeah, you can.
So good afternoon, everyone. I'm Michiel, and I will present you the results of my thesis, Hypothesis Search. We will start with the quick overview of what will be discussed today, but I'll let us start with the introduction. What is the problem that we want to solve? That we want to improve the interactive search tool. We also want to add some extra metadata to the artworks. Why do we want to do this? Because this is all very time consuming if we do this manually for the museum. So we want to try to solve it with AI. What is the part of the solution? We want to evaluate some metrics. Also, we want to cluster the labels. So we want to cluster the poses. So can we add labels to those poses? And finally, we want some semantic captioning and then some text-based retrieval with it. So in preliminary test, we found out that cosine similarity was not the best metric to compare poses because some poses yielded very high scores, unlike they are not even similar. So we explored some other metrics like OKS and PCK. Like OKS works like a bit kind of intersection over union, but for key points, and then we have PCK that works with hard thresholds, either it's inside or outside the threshold. Then we want to also evaluate those three metrics. So we conducted a sensitivity analysis with the following transformations to those key points or to those poses. We added some variation to the joints, some rotation, some mirroring transformations, and as well as scaling transformations. First, we will talk about the joint results. What we found out is that cosine similarity doesn't seem to be like affected of those noise added, whereas OKS degrades linearly and PCK almost drops instantly when there is some noise added to it. The following test is the result test. So here I only show the improved version. So when the pose is taken, the pose is increased with 15 degrees until up to 90 degrees, and we also applied progressive analysis to each of those metrics to be rotation invariant. For the mirroring test, we did somewhat else. We took the mean of each pose, then we flipped around the mean of the center of the poses, and then we applied again progressive analysis to maximize the alignment of those two poses, and then we get the following results. Whereas OKS and PCK degrades where we suspect that it would degrade when the noise is added, and strangely, cosense similarity doesn't seem to be affected much about it. And as last, we have the scaling result, where we have now an example of before and after percussus analysis applied. So we took a scale factor from 0.2 to up to 2 in steps of 10. And then we see that OKS and PCK are much affected when it's not 1, unlike cosense similarity. And after percussus analysis applied, then all the metrics are scale invariant. So now that we have some tests, that we tested the metrics, we did a similarity search. So we took 11 poses out of the collection of the RMFAB, and we conducted a similarity search with some matrices. On top is the OKS matrix, and on the bottom is the cosense similarity matrix, where we found a great match for P5, P10. And this is also visibly shown over here and with the poses. And these are indeed visually have a great similarity. Unlike the matrix of cosense similarity, where it all yields very high scores. So this makes us questionable if cosense similarity is an appropriate metric for comparing those poses. Another great advantage of OKS is its interpretability. How does each key point contribute to the overall score of OKS? Here we have a small example where OKS scores like 80% and cosine more than 93%. And we see here that the right wrist and the right knee, the right knee is 0.4. And these key points are presented over here. So they are almost outside of the circles. So how fast does OKS then retrieve poses? With the database of above 13,000 poses, it took OKS to compare all the poses with the one you query, 1.5 seconds. If we do this for the top 10 or top 1,000, it doesn't matter. It has to compute all the poses with the one you query. But if you add some poses, like if there are more artworks coming to the collection, then this will also increase. So we took a look into approximate nearest neighbors, such as Annoy and HNSV. But the problem with those was that they yielded all very high scores, and the interpretability of how they achieved those scores wasn't that clear. So we combined the speed of HNSW and OKS as a refinement. So we arrived at a 130 milliseconds, so a 90% increase of the brute force OKS. Then we arrived at the clustering chapter. So why do we want to cluster those poses to uncover meaningful compositional groupings, such as the blue cluster could be like standing, the pink one could be sitting, and the orange one could be like kneeling, or other similar basic poses. But there are still some problems that we need to solve as the loose clusters, as we see in the left image, and also the cluster distribution is not that even, so that makes us wonder how all these poses are fitted in these clusters. So what did we do? We filter out a bunch of poses because a lot of poses missed more than 3 or 4 or even higher key points. So those were unuseful, and we reduced the data set from 13,000-ish to above 5,300 poses. And now we see that the clusters are more coherent and that the clusters are also more separated from each other, and that the cluster distribution is more evenly and just for accept the 0. And what is inside of the 0 did we find out with the interactive cluster explorer that I made. So here we can zoom in some clusters, and then we can hover over a node that shows us the cropped image of the pose with the pose drawn on top of it. Okay. If you want to, I can show you a short demo afterwards. And now we arrived at the following chapter is the semantic captioning and the text-based retrieval. Why do we want to do this? Because we want to add some context to poses. For example, if we have this pose, this could be just like standing or leaning to something. It doesn't create any context. That's why we want to add some words to it, so some keywords, and then retrieve the following image. So how do I want to solve this? I want to implement I did implement a bidirectional pipeline where I now explain the red part of the pipeline where I uploaded images to OpenAI. Then I received a description of the image back. Then I embedded those descriptions and stored everything in a file. Now for the text-based retrieval, this is an intermediate step to the final solution that will combine those pose and semantic retrieval. So here I explain the blue part is that we input a query. The system will paraphrase this, make 3 variants, because not everyone has the same way of writing down what they want to see in an image. And then we create embeddings of those descriptions and also search the database on the matching artworks as shown over here. And this is an example of where I inputted a man riding on a horse. So in conclusion, we found out that OKS is the better metric with processus analysis and implemented and also mirror invariance. We sped up the whole process by using a hybrid system with HNSW and OKS. For the clustering part, it is very sensitive to pose estimation noise. And I also made a mistake in using the kind of embeddings. So better approaches to create those embeddings would improve, I think, a lot of those clustering part. And finally, I found some limitations in the querying rephrasing due to semantic drift, because when I said a man riding a horse, one of the variants was like man following a horse. So that is one part that there's some drift to the queries. What is then some future work that I like to do is also implement or use other human pose estimation for artworks, that the annotations of each pose is better annotated, and that we maybe can extend those database full of poses. Look into more advanced or better ways for those embeddings to get better clustering and maybe sub-cluster those clusters to divide even further. And also one of the more important things is the multi-search integration, so that we can use poses with keywords and then find the final artworks. And this is what, by combining the 2 pipelines, the pose pipeline and the semantic pipeline, and then also maybe add some icon class based classification. Thank you for your attention. Are there any questions?
Okay, thanks. You well in time, so good, clear presentation. Good. Now we can go over to the questioning. I see that there is someone.
Yeah, Mark has a colleague of Lisa.
Okay. So yeah, don't forget to also ask Mark if you would have questions. It's okay. I want to start with the question. So regarding the post search and the post retrieval, did you also think about a more hierarchical approach to search? Because now I think you do a one-on-one search. You compare, I think, your query with all results in the database, or is it already a bit more smarter that you do this comparison?
Which one do you mean? Like the pure OKS?
If you go back to the slides, there you the next one.
This one?
No. There were some results where you say you compared it, and that it didn't matter if you had 10 or 1,000 pictures to compare with, or 10 or 1,000 points to compare with.
That's the H and the
Yeah.
W.
This one?
Yes. So how much optimized is this search process already?
So how optimized? So here I use the approximate nearest neighbors. So this is already a hierarchical indexed file that is made for retrieving poses fast, but it has to deliver some inaccuracy for that. That's also why I refined it with the OKS. And what did I do to implement this? As I retrieved the top 2000 of HNSW because I did pure the top 10 or top 100. Those scores and those artworks that were not similar to the ones that I brute forced with OKS. So I found out if I go a little bit further, find the top 2000 and then refine, I still speed up the process and get these same results that I got from the OKS, from the brute force approach.
Okay, that was not entirely clear for me during the presentation, but now.
So it's cosine and OKS.
Yes, indeed. Behind the scenes, it's indeed on cosine.
Okay, and regarding the viewpoint impact or the perspective impact, does it have an impact, or do you already take that into account, and do you already do any kind of transformation to real world coordinates of your poses, or
can you?
If you would, for example, have I don't know if those paintings existed, just something I was thinking about, that it's not always that you have a perspective that like we have now. Sometimes you can have top-down perspective on how it is painted. Probably then of course your pose will be something completely different, although it can be the same pose. But it's just because your image coordinates will be completely different of the pose that you retrieve. Do you now work with the image coordinates of your pose? Or
Yes.
Yeah. Okay.
Yeah, indeed.
So if you would have the same horse rider pictured from above,
No.
then you would not. Yeah.
No, that's not implement. Or that's not.
I don't know if it's an issue. Probably.
I don't know. I don't think so. That's a big issue for the museum because they want to depiction or show the artworks, and they want to try to retrieve those artworks that are painted. So, if I understand the question correct, is that you want to like give a new perspective to the art?
No, I was just wondering, do there exist paintings
okay.
with this kind of perspectives?
I do not know. No, I do not know if I didn't see any paintings in the collection.
But
That,
your conclusion now is that based on what you've seen, based on the data set that you explored, working with just the image coordinates of the
Yes.
poses is okay.
Yes. So, and if there are any perspective that is painted from above, those poses wouldn't be recognized, I think, because in artworks is very hard to recognize because of the style that is applied and the not the amount of data sets that exist for artworks to train models for pose estimation is also kind of small. So in that way, it's not optimized to get, I think, other perspectives, or to get others' perspectives.
Maybe a bit related then, if you look to the misclassifications of the errors that you still have, what are the main reasons then for those?
So do you want me to show the demo? And so in that,
Show the demo, you can just,
yeah.
you want to answer the question, it's up to you. It's good to show the demo if you have one.
Yeah, okay. So here you can see it like this was more of more like standing, and then here some of those poses were like missing key points, and then the overall clustering was like the like you saw there was like more of those poses, all of them, and that was clustered into this. So I do not specifically know what would directly be needed. Does subclustering help to improve those noisy poses? This is still one thing that I
So missing key points is one.
yeah, big thing.
Yeah, because you have a lot of occlusion.
Uh-huh.
That's
And there's still a lot of variation within
But
the
there is a lot of, indeed a lot of variation, and what do I think this caused in first instance? In time of making it, I did not fully understand what a embedding was. I used the NHNSV index file to do this, but now afterwards I saw that I made there a mistake by going up from, like, say, a flat vector of those poses consisting of 24 key points, because we only take a look at the bottom part of the pose. And instead of going from 24 dimensions, I went up to 128 dimensions. So this was, at the time of making, I did not think that through. So, but I know now that I have to go down to make those embeddings to then cluster, or maybe cluster directly on the poses. That could be maybe also be a good approach to do this.
Do you think the problem here is because the embeddings are not optimal enough, and the similarities between embeddings are not optimal enough?
That's a great question, because I made the embeddings again using then lower dimensions and going from 24 to 8, or directly cluster on the 24, and I didn't find any improvement, any great improvement to the clustering. So I still have to look further into this. How can we optimize it? Is it indeed something to the embedding, or do we need to subcluster? I don't know how you subcluster a cluster, so, but I don't know how good it would perform on those clusters. So that was my next approach, to try to subcluster. Maybe does a DB scan or HDB scan, then mark them as noise. That would be also a great thing. So
because you would think that the embedding would be quite okay, because you have the rotation variance, you have the scale variance. You also did something with noise, which I didn't fully understood. That just moving some points around.
I will go back to it.
No, you don't have the invariants.
So what I did is, like, you have the ground truth key points, the ground truth pose, And then what is useful in for especially for an artwork is that we add a little bit of variance. So if the pose is like this or like this, how much does it get affected by adding noise? When does the similarity fail to recognize the same pose? And that was the thing that I want to test with the OKS, BCK, and cosine.
But from
Because
the tests, like the ODS was quite invariant to all of those things.
Yeah, cosine was didn't show any effect. I did it on multiple ways. I did it with the image coordinates. I did it with the scaled coordinates, and it still gives me these results. I do not fully understand why it would do this. If you see the scaling of the variation that I applied to those poses, I would suspect that it would degrade in some way. But if you look to these results, it goes to 98%. So
Yeah, the cosine.
yeah, the cosine indeed.
And you tested those 4 things. Did you also test the impact of missing key points? Because I can expect that.
Yeah, indeed. That was also one of the tests that I wanted to implement. I did not do that. Uh, um, I did not do that because I had in my mind, and afterwards I regretted that I don't do it. But I had in my mind because I read about OKS, it has the ability to like skip the missing key points, because then you have like, okay, these key points are visible, these are not visible, and that was one of the greatest advantages of the metric, that we can specify, okay, key points are visible, not visible. They are there, but not. So that was one. So indeed, that would be also a great test to compare the metrics. But I think you can in each metric implement some kind of visibility of the key points, but still a great test.
I've also noticed that you said that you've been working on the coordinates of the key points themselves. Is that a choice you made, or is it just the first thing you did and not did anything else? Because
How do
there would be other ways, for example, looking at angles between joints or things like that, like other ways of creating your embedding, your pose embedding, that might be more generalizable.
Okay, so do you mean like that I only looked at the pose coordinates?
Yeah.
Or the key point coordinates? Yeah. I indeed looked at the key point coordinates. Yeah.
Yeah, because if you use angles, for example, then you have your scale invariance like for free. So there are advantages with other approaches as well. So
okay,
not
no,
sure how
yeah.
far you did the exploration in that regard.
I did not indeed explore the path to compare or cluster angles between limbs. That would maybe, I don't know. That's indeed a great.
Yeah.
How do you say it?
It's a long time ago.
Yeah.
And because the post demo we used it
Normally that's
used
angles.
angles, and that gave very bad for us.
Yeah.
Not very bad results.
But that's mainly, I think, the matching. That's not very good. But the concept of angles by itself is a valid approach. Someone else with a question, or do I continue? Yeah, okay. At the last part, you're using purely the image to then get some description of a part, for example, the man riding on the horse. And then you use like your text-based search, which is certainly valuable. But could you, the first part is all on poses. So could you also use the things that you develop now on the text-based key point retrieval stuff, and like use that within the post search team again, because that's the topic.
So your question is that can we use the semantic part that we made in our post retrieval pipeline?
Link it back to something with poses again, that you don't need the image.
What I think is that the next step could be is like within the description over here, if I can zoom into it, there are some tags. So those tags are then like key tags of each image. And I think if we like got the, let's for say the top 100 tags or something, or the top 20 tags, so that we add to the post search machine, that you input a post, add a some tags or keywords, and then combine those to find the appropriate images. If that was your question, if I
Yeah, it's quite a broad question. I was even thinking of something else, and that would be to use those tags, for example, but then use those tags to let a deep learning model generate embeddings, which might be better. Then you have your image like part just as some kind of data labeling pipeline to just get the tags, and then you can create your own post embedding model where you don't have to engineer your embeddings yourself, but you let them learn by the model. But yeah, that's more like future work question. Yeah, okay. From what you've seen right now, what is your preferred approach to search? The post search or the
for me, I found the semantic search very fun to do, because if you think about it, it's like a computer that described images, and then you just want to search through those images. And for me, it's kind of mind-blowing that we are so far to do this, and that it's possible to search just on images with words. That is that's something crazy, and
yeah,
it's fun to do. Yes,
that one is the closest to valorization, probably, according to
then too.
It's the closest to valorization to really bring it to the museum, let's say.
Because also I looked around on the internet, and iArt is also a website that makes it possible to search on artworks based on texts. So that would also be a great add-on for the museum, if they can maybe digitalize or make their artworks searchable. I can also show you a demo of that. So over here, yeah, I can choose the amount of tiles shown per request, and then I enter a man riding a horse. Unfortunately, I did not scroll down, but over here the results are shown with the match beneath each image. Now I'm saying man holding a sword while riding a horse. And this gave the following results. So I think this would be a great add-on, maybe for now, for the museum to extend their search capabilities, because if you go to their website, it's mostly on artists and years or something. There's some metadata that do not people much know about.
What is the caption used to create semantic embeddings? Is that a
OpenAI.
but what
the embeddings. The embeddings were made by the mini here, the all mini LM.
It's not based on caption. It's based on. Oh yeah, you can do it multiple ways. I thought maybe you asked You combine the text query and the image could also be
yeah.
to make it focus on the pose. So now you have, okay, but these two are not related, right? You have your pose search and you have your semantic
Indeed,
search, but they are not mixing.
not yet.
That's the future work part. Okay. I'm so confused about what we did because the start demo had the angles and we didn't have good yeah, okay. One last.
Maybe one question I have is one of our colleagues in the team, Winter, also did some research with pose estimation and so on. He also experimented with more 3D pose estimators. Is this taken into account?
No,
considered?
because every artwork is 2D visual, is 2D presented.
Yeah, but you already have models that can generate a 3D
Yeah.
pose out of 2D image,
Yeah,
but
so,
you did not
yeah.
test it or evaluate it if that would work on artworks too.
No, I did not do that. I did not
I think
evaluate.
it does. I've seen some demo, I'm not sure if it's all from Winter or from someone else's, but they did apply those magic overlays on paintings and I think it did work.
And because yeah, it relates a bit back to my previous question, because then
You get the other.
yeah, your angles, etc. I can imagine why angles will not work, because yeah, if you just move your camera a bit and you just focus on your 2D angles based on picture coordinates, then it becomes very difficult to define them as two similar poses when they are shot from two different viewpoints. While if you would have a more 3D based approach, I think solutions could be found maybe to solve it. But you did not test those.
I did not do that.
Stones, yeah. Okay. And are there then any type of artworks that work better than others? If you
Yes.
focus on types of artwork, what is your suggestion? Are the museum would want to start with this? On which collection, on which subset would you say do it on this one, and you have a very nice demo for the public to work with? Because of course there's a risk to do this on the entire collection, but maybe they have a thematical event soon that you can guide them a bit for these type of events. This would be very
So what I would suggest is try to get images that are not too black white and that have great contrast. I would also suggest to not to go to abstract arts, so that the models they want to use for pose estimation can find those poses, and if you, I think, especially not too occluded figures is also important. Too crowded where there are too much people, even small peoples, is also a kind of problem. So that would be my main suggestions, that go to specific art historical artworks, not too abstract, not too yeah, the sculptures also gave some bad results in the collection.
Like for this thing, you did like the study of invariance. I don't think I think like an objective validation on the performance of your similarity matching is indeed not as straightforward. I guess you saw the original demo of poster search.
The one still implement on the website, yes.
Let's say, for example, we take your research now and we put it in that demo. Do you think it will work?
Yeah.
Better, much better. Like
much better. So that is
feeling.
an objective feeling of, how do you word it in English, but is that I've implemented it in the search tool now, and we retrieved poses back, but the scores are much lower than you get from cosine. So that is also why I have this. So cosine similarity again does not show how is the contribution of each key point is, and for that I found it sometimes hard to use because for the explainability here you can also tweak those sigmas of those OKS per key point if you want to, for example, say this needs to be bigger the shoulders and the hips. That could be made wider. So, but for the search tool itself, I think that OKS is a better metric because it's explainable why those key points or those poses are so good or so bad.
That you like draw someone kneeling, then you also get the results of
Kneeling is
Same
not
things
taken
work.
into account for, or drawing is not
Yeah.
taken into account, but if you would, for example, choose one of the predefined poses in the search
like
tool.
click and drag stuff,
Yeah,
so,
yeah, indeed.
then it would give better results than
I think, my opinion is that indeed it gives better results. But indeed,
Like your top K is maybe an indication of that. I mean, if you put it too low, but you work with cosine first. If you put it higher, you get better results. Actually,
Mhm.
knowing that the cosine proof search is not very selective.
no.
Hey, you have questions?
Yeah, here is the point that it's not really clear for me. Just for the post with missing key points.
Mhm.
So in your data set, how did you define your filtering threshold?
Here, so can I also. So here are two beautiful examples of what much poses were. Is that some key points of the heads were annotated, and then the rest was blank. And how did I do it? I took the everything of the body. I looked at if it is missing two or more key points. Then I said, okay, this is not useful because sometimes it was like a hip missing or something else missing, and I thought with making it so small of two key points would be maybe just a arm or a leg or maybe both feet if it got occluded. So that was my thinking of filtering out those poses. I also went a step further, like there does not need to be any key points missing. So with 0 key points missing, and I clustered then, and this gave me just 3 clusters, -1, 1, 0, and 1. So that was not also the good approach to do this. I hope it answers your question.
Mark has any questions? Any topic?
Yeah, well,
You can ask it directly to Mark yourself if he has any questions.
Do you have any questions, Mark?
No, that's nice of you. Thank you. Thank you for the presentation. But
Is your audio on? Oh,
yeah.
yes,
Okay, yeah.
you can hear me.
Yeah,
Yes.
I can hear you.
Okay, thank you. But I don't have any questions. But thanks for the presentation.
okay. So, any final question then, someone? You're through them.
Yeah, most of mine, like I or intermediately asked them or so there's no there was a smile. Is there a reason to not immediately combine to always include your cosine? Because it feels like in this approach not very useful. So you have your HN
HNSW.
yeah. It doesn't need a cosine, right? You can
Indeed, you can use like an Euclidean distance. If I'm guessing it that you meant that the back.
yeah, but I would use your OPS directly in your
So it is possible, but then you have to tweak a little bit the OKRs to do this, because it needs to be not only fast, but it needs variant sizes. So it converts the input that you do to a specific dimension,
Mhm.
and then your metric needs to be um, fitted, needs to be adjusted to get that kind of vectors in to calculate it.
Or even just use your clustering and as an index. Because you now already calculate 2000 distances in a query, I think, to re-rank. So if you basically have 20 clusters, you would have the same number of comparisons to do, I think. Am I right? Roughly. And you create basically your own index structure. I'm just thinking a bit about the gains of using. If the refinement is so many comparisons, then it's maybe not necessary to do a very quick index structure. I'm just thinking out loud. Unless I'm wrong.
I get what you mean, but yeah, that's an experiment on its own to see if your indexing technique is indeed yielding the useful index then.
Yeah, now it feels a bit random, because if he makes it bigger, as he goes from top 500 to top 2000, he gets better results after refinement. So
good work with that,
because it's using cosine in the beginning. Maybe if he uses OKS clusters, I want to use only OKS.
Okay, yeah.
Then your own index structure will probably. But it's just future work, but.
You could also do some kind of PCA on your embedding, and then you can already use some kind of pre-indexing based on
The cluster picture you showed me didn't need any cosine, right? Or am I mistaken?
That's purely on the poses, if you want, using HDB scan or DB scan itself.
All right. Then I think we can close the explanation. Thanks for your presentation. So yeah, as I said in the beginning, you will get news about it next week. Enjoy.
Thank you.
I think now it's summer for you.
No,
But you still have exams.
Computer graphics.
Okay.
20,
Tomorrow then.
27th. So
Friday.
yeah, it will be a lucky guess.
Then if that with your last item.
Don't say it too loud. He's here.
Okay. Thank you very much for everything, for the support, and also great thanks to Dieter and Kenzo.
We will inform Kenzo.
Okay. And